And if you do it correctly and do g of 1 plus gh with all the k's and everything, MATLAB will do it properly. But when you're just looking at the root locus program, all you get are the roots. Here's how you would plot the root locus by hand. Here's how you do it by hand. And you only have to know 3 rules, right? So and the 3 rules are going to be popped right out. So RL by my CLTF is equal to G over 1 plus GH. Where the K's are embedded in here and polynomials and S are embedded in here. So, these are functions of S. So, can I say that the roots of 1 plus K, can I say that A are the same as K, R, L, G, and I'm going to put the S in there now, H of S equal to minus 1. Can I do that? Pretty simple. If I want to plot the closed loop roots like the root locus does, can I say that the root locus is just picking values of S where this function of S equals minus 1? If this is equal to minus 1, do I not have a root of this transfer function? Yes, I do. Now we know that the angle, the minus comes from the angle. So all I have to do is find an angle, our same as angle of GH equal plus or minus 180. Can I do that? In other words, if the angle of this function, when I evaluate this function, I made a complex number. If the angle of that complex number is plus or minus 180, well then that value is on the root locus. So if I could pick a value of S so that this function, so here comes the problem. I want to pick values of S. We call those trial points. As trial points, evaluate GH, G of S1 and H of S1. Okay. And that's kind of the secret of what we're going to do. So I'm going to show you now how to do that with this example. So here I've got a case where I have I've got a pole at the origin, and I got a pole out here at minus 10. And I want to find out where the root locus lies. So let's pick a trial point over here. We'll say that's S1. So this is going to give me, that's going to result in 10 over S1 times S1 plus 10. Okay? Now is when the magic starts. After you come up to me, I'm going to show you how we do this. What is S1 on this curve? Can you visualize that trial point in this curve, S1? Can you make a phasor out of that trial point, S1? You see it right there. What is S1? Is it not this? That's S1. The phasor drawn from the origin to the trial point is S1. So if I were to call this a phasor, L, and I'll call it LS1 or P1, whichever you want, so then you can replace this with equal to 10, and then I'd have magnitude of LS1, and that's a phasor. What's the magnitude of that phasor? Whatever my trial point value is. If it's 10, it's 10. What's the angle of that phasor? What's the angle of that phasor? The angle of that phasor is 0. You measure the angle from this axis counterclockwise. That phasor is lying on that axis, so that angle is 0. So this becomes a magnitude, and this has an angle of 0. I'm going real slow, right? So just to catch you up on it. If you don't follow me, you need to look at those complex videos I did. There's 4 of them on there, and they'll handhold you right through this, what I'm going through real slow right now. I've got S plus 10 over here. How do I get this one? Well, S1 plus 10. Well, what S1 is what? Is this guy, right? That's S1? What is plus 10? Well, plus 10 is a phasor drawn from here to the origin, yes? So that's plus 10. S1 is this, so what's S1 plus 10? If this is 10, and that's S1, what's S1 plus 10? It's a phasor drawn from that pole to the trial point. S1 plus 10. What's the angle of it? What's the angle of that guy? 0, right? So the angle of this other guy of L, what can I say? It's not under Locus. Because what does the angle have to be? It's got to be what? The angle has to be 180. The open loop transfer function has to be plus or minus 180. So that is not under Locus. Let's put that, and we'll call that S trial point, another trial point, S1. So I've got the same formula over here, but what is S1 now? Well, S1 is this phasor, isn't it? Right? Let's say that's omega D. That distance is omega D. So what would this first phasor be drawn from that pole as S1? It looks like it would be omega D J, right? What's the angle of omega dj? What's the angle of omega dj? 90 degrees, yeah? So I have 90 degrees from that guy. I got 90 degrees. And when I move it to the numerator, it's going to be minus 90 degrees. So I'm halfway there. When I draw this one, what's S1 plus 10? Well, that's S1, yes? That's S1. Now watch, everybody, watch this. The 10 is still like this. That's a phasor plus 10. So what is S1 plus 10? What is S1 plus 10 adding vectors? I'm adding these two vectors. How do I add those two vectors? Like that, right? That's S1 plus 10. So this is S1 plus 10 when my trial point is on the j omega axis. So this guy is going to be j omega d plus 10. Yeah? But here's what I want you to see. I replaced this with a phasor drawn from that pole. I replaced the value of this function with a phasor drawn from that pole. That's what you're having a hard time seeing right now, because I had a hard time seeing it. But once you see it, it'll all click. You know? If I want to evaluate that at a trial point, I just draw a phasor from that pole. That's it. So I got j omega plus 10. What's the angle of this j omega plus 10? Well, it's going to be a little bit less than 90 degrees. It'll be less than 90 degrees, right? So I have 90 degrees, and this is going to be less than 90 degrees. So when I add them up, I'm not going to get 180. If I pick my trial point over here, and again, now I'm starting to skip a step. I'm starting to draw my phasors. I'm just going to draw the phasors. If I pick my trial point over here, this first phasor, S1, is going to be from here. What's the angle of that? Minus 180. Now I have a second phasor over here. It's going to be minus 180. When I add up minus 180, minus 180, what am I going to get? 0. So it's not going to work. That's where you're half wrong. But what if I pick it here? If I pick it here, if I pick my trial point here, then from this pole, I get an angle of 0. And if I draw the phasor from this pole, I get an angle of 180. Bingo! So any point on this part of the real axis that I pick, any S1 that's drawn to that point is going to be minus 180. Any phasor S1 plus 10 from the 10 is going to be. Now the hard part is replacing these with the phasors. You got to make that trust. You got to trust that the valuation of this polynomial in S at a trial point, you have to trust that the evaluation of this is equal to a phasor drawn to that point from the pole. That's all I'm asking you to believe. Work it out as many times as you have to until finally it clicks in. Oh, I get it. The value of this is equal to a phasor drawn from this pole to that trial point. It has a magnitude, it has an angle. It's a real number. It's a complex number. And all I'm saying is that complex number has to have the angle of 90, has to have an angle of 180.
So our trial point should be between the pole and the zero?
Yes. So Peter has got it. The trial point has to be between the pole and the zero. Therefore, my root locus has to be between the pole and that, the two poles. Now, do you see that that's going to happen whenever I'm to the left of an odd number of poles? Whenever I'm to the left of an odd number, that same thing is going to happen. So that's where the first rule comes from. The first rule comes from if you're to the left of an odd number of poles, that's on the real axis. What about zeros? What if I put a 0 up here? S plus 8. That's going to put a 0 over here, right? Well, I have to put a phasor up here for this S plus 8. How do I evaluate the S plus 8 for a trial point that's out here? Well, I draw a phasor, and that goes in the numerator. That phasor has an angle of 0. This phasor has an angle of 0. This phasor has an angle of 0. Not on the root locus. But what if I go here? What if I go between the X and the O? Well, from this 0, that phasor is going to be 180. This one's going to be 0, and this one's going to be 0. Bingo. So the rule is, to the left of an odd number of poles and zeros on the real axis, that is where your root locus lies, because of the angle condition.